So we are going to do not that. Don't look at the answer. No, I mean, yeah, it doesn't matter. So we're going to do this one. And then if you look ahead, we're done with that section. Wow, that was so fast. So I've actually gotten these right. I'm not getting anything wrong yet. But this is going to be an early class because I have to leave early. I already told y'all that. So here we go. Find the volume. Um, Without going into all the craziness that we did last time, double integral of stuff, and then we're going to pick our dy, dx, dx, dy stuff. What would y'all want?
I almost want to say because we have different values for the integrals, like I forgot what it's called, basically like the 0 and the pi over 6. And since it starts with x, I would assume we can start with that dx.
Okay, if you want to do that, dx, dy.
So you can choose what you're going to do.
Yes, yes, indeed. Yeah, you can choose whichever one you want all the time. Sometimes it might not be advantageous. That'll be something we learn in the next section, switching it around a little bit more. But yeah, that's fine. So I have to say, because two of y'all weren't here yesterday, this is an unusual configuration. I normally do dy dx personally, but dx dy is no problem. So let's do it. If this is the case, what goes down here? What goes on the bottoms? Oh, hey, I thought you weren't going to be here. Stephen had said, oh, no, she's not here. I was like, I'm glad you're here. Anyways, what goes in the bottoms down here? Pi over 6, very good. You just walked in and you're, boom. Oh, see? So yeah, and that's the interesting way to think about it. First, it's kind of a weird thing. So I'm understanding what you're saying now. Yes, okay, gotcha. Okay, good correction, good correction. Um, the main thing is that x's with x's and y's with y's. So when I start doing this integral on the inside first, it has to have all the x's. And so that's cool. So let's do that. What would then be my integral in terms of x?
That'd be 6 cosine y.
6 cosine y, because that's the constant.
And then sine cosine x.
So this part right here turns into a sine, a positive or negative?
Positive, because it's moving upwards, not downwards.
Very good. Yeah, exactly. You're integrating, right? Very good. From 0 to pi over 6. And again, we should technically be saying this is x equals, but you know me, I just kind of slap it around. So essentially, it's like a partial derivative, but now it's a partial integral. I'm just going to say whatever's not with my variable, I leave it alone. And if it is my variable, then I take the integral. Plugging in for, wait, do you see what I did wrong? This is an x, my bad. My bad. I even had the x's right there. So plugging in, whenever I plug in a 0, what do I get there? So that's kind of nice. So I'm leaving this guy alone. Plugging in pi over 6, 30 degrees. Sine 30 degrees? Okay, yeah. Yeah, I'm getting confirmation, okay? Thank you. Good confirmation. 6.5 makes a 3. I'm going to slap it in the front because might as well. And so we're left with something kind of easy now. What's our integral of cosine is? It's as if you never left. Yep. 0 again makes it 0. Plugging in 60 degrees. Perfect. And we already saw the answer, so that's it. We did it. Cool. Very simple. Pro question for y'all too. Good? Yeah, nothing to be scared of. These are easy things, and that's a good thing. Much better than Lagrange. Much better. because I'm not getting them all wrong. Yeah. Cool though? Good, good. How's the writing? Is that okay so far? Okay, good. Okay, glad it's working then. That's good. Okay then. Ready? You ready? Good. Okay, you shrugged, so that means a yes. All right, so more double integrals. Again, I want to do labs, but I want to do it like next week. Tuesday is what I'm thinking. That way we have maximum coverage after spring break. Tuesday after spring break, I'm thinking of doing the labs. I'm okay with that, bro. I'm okay with that. I would love to have y'all. I wouldn't cook, but my wife would. um, anyways, so double integrals again, but this one's just more generalized stuff. And so what they're trying to say is that these guys right here are functions. They're like little mini functions, and it doesn't have to be with y. It could be also with x. Just depends on what we're doing. They're not rectangles. Now they're circles or triangles or who knows what. And I just put a picture in there because it looked cool. I mean, really, there's nothing there. Oh, I hate multiple choice. So I think what they're wanting to do right now is just say, can we figure out the region? And if you remember from last time, they put the little r down here, blah, 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 dy dx. That r stood for region. And again, we also saw something here instead of dy dx. What was it? Do you remember? It was dA. A stood for area. So we're looking for the area of the region, right? We're looking for the same thing essentially, an area region. Which one would make sense for what we got, right? So what I'm looking at is, first off, this is a y equals 3x squared. This right here is a y equals negative 3x plus 60. And those are my functions. And so, like, I want to graph those. So I know what we're looking at here, but I want to just graph it on my own, if that's okay. Here we go. So I got 3x squared. Whoosh, whoosh, right? Not too bad there. This is a line. I'm starting at 60, which is pretty high, and I'm going down negative, kind of slope like that maybe. I think that's good enough. So which one is it so far? Yeah, it's one of these two guys, right? So at least we 50-50'd it by just looking at them as functions. Now I need to know which x values we're looking at. So it says here x is equal to 0, x is equal to 4. So 0 is right here, and I'm guessing 4 is like right there. And so I'm guessing it would be this guy. Do we have one for that? There it is. And you could see right here, where is this ending? It's at 4 right there. Cool. That was it. That's what we do. We're just looking. Do y'all like multiple choice? Yeah, I know. Do you want multiple choice for your exam? Sure. And then the other one, you circle one, and in your blue book you say the other one. And I'm confused. I have to get points. Yeah, I know. That was a joke for everyone online. That was a joke, okay? Yeah. So this is a two-part problem. They want to do the little region graphy thing and then also find it. This is going to be the fun part, obviously. So looking here, what I have, let me rewrite it bigger, if that's okay. We have x equals 0, x equals pi, and we have a y equals 0, and a y equals x, and then we got stuff dy dx. So that's again what the bigger picture is. Let's graph it. What does y equals 0 look like? Yeah, x-axis, exactly, a flat line. And then y equals x is a diagonal 45-degree line. So those are my two lines from that. They're saying go from 0 to 3.14. So 0 is obvious. 1, 2, 3, and a little bit. Right? Because they're just saying Like, where's pi? It's just 3.14. That's my guess. Right? Cool so far? Easy enough? Is drawing the picture important to getting our answer here? You said no. I agree with you. Not right now, at least. When it gets more complicated, more difficult, yes. But right now, they're just starting to introduce it. They're just saying, hey, can we do this at all? And then, yeah, this doesn't have anything to do with the graph, obviously. So let me just re-expand it here, and y'all are going to help me all along the way. Because now it should not be too much different than what we've already done. So first off, we're doing the y's. I need to take the integral in terms of y. So that sine will turn into a... I'm going to also take the 3 and move it out because it'll be annoying otherwise. You're okay with that? So then I have an x times cosine of y. Again, I put the minus on the outside already. From 0 to x dx. Literally no different than what we've already done, right? It's just that last time it was all numbers. This time it's a letter. No big deal. We could do this. Whenever I plug in the x, we get cosine x. I mean, yay! I mean, that's what we got, right? Right. So then we plug in the 0. Right, x times 1 parentheses. Yes. You got it. Good. Yeah, distribute. I got you. Just took me a minute to simplify. Okay.
I can see that you factored out an x.
Either way. You're right. I probably shouldn't factor out an x. You're right. I'm going to go back and just put the x out right here because I'm going to be integrating, right? And I want to integrate it nicely. And it's way easier to have it split. At least I think it is. So now we integrate again. What's the integral of x cosine x? Oh, you don't know?
Wouldn't that be integration by parts?
Yeah. So, thank you. So that, remind me here, it's my integral of u dv is equal to uv minus integral v du.
Yes.
Okay, well, I'll have y'all do that one. I haven't done this in a while, okay? It's been a long time. So bear with me a bit. Let's say, and I think what the thing is that you want your u to be the easy one that's going to get rid of it, because then du just turns to a 1, right? I think that's how you're supposed to choose it. My dv, I'm going to say, is the cosine. So therefore, when I integrate that, it turns into a regular sine. Oops, this needs a dx. So following the formula, I got x times sine x minus integral of sine x dx. And then I still have this guy. What's the integral of x? Yep. You got it. I'm going from 0 to pi. Is it getting hot in here? Okay. Or is it just me getting nervous about integration by parts? Yeah, that's very true there. So integral of sine, that guy's going to turn into a cosine. And yeah, notice that we got negative cosine with a negative should end up with a positive cosine in the end, essentially. So x sine x plus cosine x minus x squared over 2. Again, all from 0 to pi. Plugging in the pi, I get all kind of random things. So I got a pi sine of pi. What's sine of pi? Oh, okay, well that's easier then. So this is a 0. Cosine of pi is a -1. And then this guy, All right, pi squared over 2. Yay! Notice that I switched the sign right here because it would have been minus. 2 negatives make a positive. Plugging in the 0. Sine of 0 is a 0. Cosine of 0 is a 1. This guy's a 0. These two are negatives. Wouldn't that be a positive in the end? Right? So then we got a positive 3, another positive 3. So I'm looking at positive 6. And then I got this thing, which is all kind of funky. I don't know what their answer is, but I want to go see. Yeah, let me go flash the answers. Did I not distribute the 3? Oh, to the pi. Thank you. Gosh, man, I know I would have made one little mistake. Thank you. Thank you. Okay, very good. Okay, well, we're really close to the answer. It's positive because 2 negatives make a positive. Man, would y'all give me some credit? Right? Would I fail my test over that? No? Okay, thank you.
Was it minor error and you know your math, so therefore 0.5 back?
Minor error, I give you like 80 or 90.
Oh, I'm thinking major error, sorry.
Oh, it's a major error now, is it?
No, I got the values of how much mixed up.
Yeah.
Thank you, Ryan. Thank you.
It's funny. All right. Aside from my small mistakes, not too bad, right? In the end, all we're doing is plugging in letters instead of numbers, and that's okay. We could do that. Do you think you could do this for the rest of the class? I mean, that's essentially what's going on here, right? Because, like, we're just going to do integrals for the rest of the class. That's what we're doing. So that's okay. Oh, the rest of the course. Yeah, the rest of the course. Yes. Because I have that crazy meeting coming up, I'm seeing if this is a text message I need to, like, respond to. Sorry, guys. How about that's a you do, all right? Yeah, you got LNY. You get to figure that out. In class now. Yeah, sorry. They're saying, hey, we're right outside. Can you come and see? I'm like, no. I'm actually in class. You're here an hour and a half early. I will be there soon. Okay. Oh, y'all are actually doing it. Good. Yeah. Set it up. Try it out. pausing on mine. Yeah, that's how I feel right now. It's like we got to this point. What do you think about my stuff?
Interesting. I haven't figured out the graph part yet, but
Oh, I don't care about the graph part.
okay.
Hey, Desmo's graphing, duh. No. Yeah. Just chilling out. I don't mind waiting. I mean, I got them honor lock folks waiting in the parking lot. I don't care. Y'all come first.
I have no idea if I did the math right, but I got something.
You got an answer?
Yeah.
Oh, that's cool. I don't know if I'm right. It was a little harebrained at first. Here, I'm gonna try something else while we're kind of just chilling for a minute. I have an idea. Here, don't look at what I'm doing. Just if you're online, look at what I'm doing. But if you're not, then don't look at what I'm doing. Chad, you are being a very bad boy. Yeah. Yeah, we're gonna see. We're gonna see. Dx dy. I mean, it's something. So divide by pi. No. There's something going on.
Which is actually kind of close to E.
396528. Ooh, look at what's coming up here. So is this gonna be? We're not. No. It's not the same. No, is it the same? It's really close. Really close. Let's just kind of look around. So I don't know if that's it. We might be just being funny for a minute. Can you do double integrals in Desmos graphing? Yeah. Should I have shown you that? I don't mind. You can't use it on the exam yet, but for your final, I hope you do, because some of these integrals will take way too long. And also look at what our response was. I mean, it's a good way to double check. You can't really get what we really want out of it. So it's close. It's at least helpful. So yeah, let's figure out what's going on. If y'all are okay with that. Okay, so I was like, okay, listen, take the integral, and the integral of e is e, right? That was pretty simple. Then I plug that guy into the x, and 0. When I plug in 0, I still have something. So I have split it up. Now, if I'm adding the powers, I'm actually multiplying their bases. It's one of those little exponential property things from way back in the day. And I did that because E and ln cancel, but I can't do it at first. I can't do it yet. I have to do it after I do like a little bit of math here. And so then it turns just to a y. I know that there's a formula that exists that does something kind of like this. And there's there's the answer kind of thing. I don't know what the answer is though. It's one of those integrals that I've obviously not memorized. There's like hundreds. So I don't want to go down that road. I want to see if I can do the integration by parts again. So I'm only looking at the first part here. I'm going to say my u is equal to the y, so that du is equal to dy, and just it's like 1. It turns into a 1. Super easy. Dv is going to be that e to the y dy. So therefore, when I integrate it, it turns back into itself. So I got, actually, I'm just going to integrate it now. I can just do that. So here's my new integral. I'm kind of like doing this. For the first part, uv, so y e to the y, minus integral of v du. And then what's my integral of e to the y is? Okay, awesome. From 0 to ln 7. Notice that what's my integral of e to the y? Yeah, so there's 2 of those guys now. And I mean, we can factor, but I want to just get an answer, you know. Plugging in the ln 7 everywhere. And then we'll plug zeros in here in just a second. So I've got ln 7 times e to the ln of 7 minus 2e to the ln of 7. You can see there's a lot of canceling going on. And then all that, I'm going to say minus, when I plug in a 0, I get 0. When I plug in a 0 there, though, I get the 2. Where are you, Chad? So 7 ln 7, and then this is a minus 2. Whoa, whoa, whoa. That 7 is still here. I think that's going to be a 14. And then plus 2 would actually be a negative 12. So let me check their answer. We're close. They have an E, and I don't have an E. We'll look at that here in a second. But using my strategy here, I can say, hey, did I do it right? And I did not. So there's something tiny going on, right? Let's back up and I was moving fast right here. I think the 7 still comes to the front. This is a 14. But did I miss an E over here somewhere? Like if I plug in a 0 or something, is there an E hanging out? Because that's what their answer is, right? Look back here for a second. See, we got this. We got this, but I have a 2 and they have an E. So like how did they get an E right here? Because if they had that, then I think we would be fine. See, minus 14, I wouldn't have minus the 2, basically. What did I do wrong? It's like, that's mine. They're saying this is a plus E. Oh, it's a plus 2, technically. Okay. If I plug in this, I get the 14. All right. If I plug in a 0, I get e to the 0 is... no, yeah, it's e to the 0 is a 1. And then that would be...
Oh, Chad, it's 1, not 0.
Ah! Now, so something to learn, children. No, I'm not, y'all aren't children. I'm just saying for... This is a 1. It was right there. So don't mistake your integrals. Stop, like actually write them down every time, children. No, y'all aren't children. I'm just making like a point, right? I'm sorry. I didn't want to call y'all that. That's what I would say to my children. Yeah. I tell my 6-year-old now, did you remember to write down your definite integrals today? Man. So yeah, you're right. It's a 1. It's a 1. If I plug a 1 in everywhere, then that changes everything. So let me go back and plug a 1 in. Are we back to the I have to have everything wrong at least once? So e to the 1 and then minus 2 e to the 1. And that's, if you combine those, it's a negative e, and then there's a negative there. So positive e there. Okay. Well, notice that again.